That would element 93. That would be like 93 electrons surrounding 93 protons. So it's a heavy thing. It's uranium. But so that's where metals are made, and carbon, I think, which is what we're made out of mostly. And so it scrunches all this in, then it kind of hangs out in this really big core. No. It scrunches it all in, and in the process of scrunching it all in, they scrunch so far in that the actual protons touch each other, which makes an incredibly strong nuclear force that repels them so quickly that you have a celestial explosion. I think it's called a supernova. Comes in, squeezes it, spews all of the extra photons, because it has to spew out photons in order to create all these new elements, and that explosion create all the metals. That it spews it out in two lines, kind of like a pole that goes directly through the sphere appears, and these lines just shooting out gamma ray, I think it's called, of pure photons strong enough to completely vaporize our planet, even if this thing happened on the other side of the galaxy. And once it does that, it explodes off into space, scattering all of the metal and carbon and stuff. And then it flies out there like in an asteroid field or something, or maybe a dust bowl of raw metals and carbon, and it hangs out there a really long time until they conglomerate again from gravity and become planets. And so our solar system right now, any solar system with planets, is actually stage 2, is a second generation star. We're a second generation star, because as these things blow up, you're still going to have a lot of free-flowing hydrogen atoms that were already in space, or that I guess didn't have their chance to burn, because there just wasn't enough pressure for them to burn at the level that they were floating at on their star. And it just blew up, turned into a supernova for that. And then so they return into a sun again, so our sun, and then all of the matter, because there's less of it than the sun, and it creates lighter planets than our sun. They revolve around the sun, condense and revolve around the sun. I think our sun is 4 billion years old, I think. And so like our planet is about the same age as the sun, right? So our sun will die another, 2 billion years or something? I should have read this, I'll do that next time. And when that happens, it will go through the same stage. They grow really big, I think, because all of these different nuclear reactions with atoms fusing, it happens with so many different atoms around, not around the core, because the core has already done its nuclear reaction and it's just sitting there, but around the edges of it, there's all these other nuclear reactions that are able to happen from higher, more density elements that are created in the middle of the star, which grows the star really. Whoopsie, my battery died, sorry. Okay, so it'll grow in size and engulf our planet in a fiery fire. But that'll happen in like 2 billion years or something like that. So this basically happens over and over again until you get more and more dense matter out in the universe, I guess. So then you might think, oh, okay, so the universe will just eventually condense again into nothing. Into that final nothingness of all the black holes will condense, all the galaxies will crash into each other, like how our galaxies in the present right now crashing into Andromeda, which is about a third larger than us, and about, what is it, I can't remember, 300 million light years away or something like that. And then we'll turn into an infinitesimally small unit and then explode into a universe again, and kind of like the universe is breathing in and out, Big Bang to Big Crush to Big Bang. But apparently all of the galaxies, or most of the galaxies and stars and everything, are actually still flying away from each other. It's just that we're going into Andromeda because we're just kind of sister galaxies. About half, or I think they're deciding that most stars out there have sister stars, binary star systems. Two stars revolving around each other. Even our sun supposedly may have that. We do have an anomaly in our gravitational field suggesting another big body of something out there. And people are thinking it's probably a brown dwarf sister star to our sun. But most of the galaxies are actually going away from each other, and we can find that from redshift scientific experiments. Because light can only go a certain speed. How fast the light goes, but even though light travels all at the same speed, it travels at different wavelengths. The wavelengths gets longer as it goes through time, because as it passes through the ether or through bumping into all the other light or something through the matrix, it gets longer. So you can look at the wavelength of a planet, of a star, and then you go back to it a year later or whatever, or a day later. I don't know how they do it, depending on how sensitive the equipment is. And if the wavelength is longer the second time, then it's going away from you, and if it's shorter, then it's coming towards you. So that's kind of causes a lot of confusion. Like, well, what next? We blow out of nothing. We didn't know what was before, and then we don't know what's going to happen next. So we're just going to freeze. It's going to be called the Big Freeze. I think they call it the Big Bang to the Big Freeze, because at the end there'll be nothing left to burn. And then, so that's the story of the creation of the universe. I guess if you want to go in and find out, well, what really happens, because that's obviously, the story isn't done yet. That's just if you're going to say Big Bang to Big Freeze, that's it. Quantum physics and all this is far from being agreed upon or set in stone, just like any other science or most other sciences. So some people have a theory of, I guess you go into the other string theory and stuff to explain what would happen, but I'm thinking, well, actually that would be another video. So that's the story of the universe. Okay, bye-bye.